See, we've all found our way back from lunch then, and we've even discovered some more people, maybe, that have woken up since this morning. Welcome. This afternoon, we have a great session. Matt Hicks has been willing to join us. He's the Vice President of Engineering, Cloud and Management, and he'll be talking about the future of development with Docker and Kubernetes. So, a warm welcome to Matt Hicks. Thank you very much.
Thanks, Andy.
Thanks, buddy. Appreciate it. Have fun.
Hey, everybody. So, obviously, I'm going to talk to you about the future of development with Docker and Kubernetes, but I have a little bit of a unique perception on this. The last 4 years and change, I've gotten to work with Linux containers as part of the Openssl team. And as part of the Openssl team, 4 years ago, we didn't have Docker and we didn't have Kubernetes. We were in really the bowels of Linux containers, working with kernel namespaces and control groups and SE Linux. Really, really powerful technologies, but the consumption was a little dicey. But we're Linux guys, like that's what we pulled together. And it's been really exciting over the years to actually see this converge to these technologies that I think are much more likely to reach the mainstream. But that's been my last 4 years. Prior to that, I was actually working in IT. I had a unique experience in IT as well because I worked on both the development side of IT, spent a lot of time cutting code, whatever languages you can imagine. Then I shifted to the operations side, and I literally carried a pager for my own code that would break and wake me up at 3 a.m. and got to see the balance of actually working across that in an organization. So we would call it DevOps today, but I spent a lot of time between groups just trying to work out the friction and kinks of why we fail deliveries and how we make these things work across different teams. And so today, when I look at new technology, that's the lens I'm looking at it through, is how applicable are technologies like Docker and Kubernetes going to be to actually changing development, changing the rate and really the pace of development. And for me, I think these are probably the most exciting technologies I've seen in a decade, not so much from the technology themselves, but where they're placed. Now, for the cynics in the audience, and I know you guys don't call yourselves cynics, you call yourselves pragmatists, you have heard these promises about 1,000 times over. So if we start with the languages, every new language that comes out, it's going to be the most awesome thing ever. The keystrokes it saves will fundamentally change the rate of development forever. I've heard it before. I am a technologist, like I love languages. I go learn them all if I can. But openly, I think languages have been very powerful in the sense that they give you new specialized tools. Some of them do allow you to work faster, but we haven't seen this just fundamental change in how development works or what you can accomplish. So the languages fell a little bit short for me in that total scope of what they changed. So no problem, we moved from the languages to the frameworks. Can't put everything in a language, right? So we're going to build these frameworks on top of it. And there's been a lot of innovation in these frameworks, from Java EE to Rails, Django, Node, you name it. These are extremely impressive capabilities that are built in to allow you to target more things above the language, whether you're writing a mobile application, maybe you're writing the next Internet of Things, or just the next generation web application themselves. But again, they didn't really fundamentally change the rate of development in the sense of from building your applications to getting them running. And part of the reason was this is they really didn't affect the operational side of the world all that much. In fact, some people, if we have some sysadmins in the crowd, one of the most common complaints about Java that you'll hear is that the complexity of the JVM, the power built into the JVM, can actually impede operations. It's harder for them to understand what's going on within that. So a lot of these capabilities we built sometimes introduce friction on the other side of the house. So if languages weren't going to get us there, frameworks weren't going to get us there, don't worry, we're going to get there in terms of process. And I've gotten to work in basically this entire spectrum, from doing waterfall breakouts to 1,000+ person teams to literally, if you guys remember, like writing note cards and pasting them up on a board with 2 keyboards for extreme programming. And there are a lot of capabilities in our practices, from Agile and Scrum and iterative development and waterfall. But again, they tend to be limited in scope. They're all improvements, but they don't impact everything across the scope of developing applications that we do. So if we look, why is that the case? Let's start with the basic challenges. The first challenge we have is we tend to talk about the world of IT, in two different teams. Literally, we are in different organizational structures. We eat with different people. We know different things. We might report and meet at the CIO, and we might not. Now, that plays out to tend to be a little bit closer to like warring factions in Games of Thrones than actually like a common team trying to work together to get a deployment out there. And if that's the first challenge, that we're separated in teams, the second challenge compounds this a lot because we know fundamentally different things. On the development side, you know coding, right? The tools of the trade on the development side of the world are coding and algorithms and best practices that are structured there. And that's really powerful on the development side. That's what you know. That's your sort of lifeblood. But then if you look on the operations side, their world tends to revolve around infrastructure, and specifically actually like software meeting infrastructure. They're going to be a little bit more apt to know things like writing IP tables rules to put in firewall rules to keep a denial of service attack at bay. Now, these challenges really separate our teams. Both teams can code, both teams can do these things, but they're different approaches to what's needed for an application, creating it versus running it. Then the last part about this, if we are on different teams, we know different things, then the third challenge is we look at our incentives. Right? What are development teams incented by? Incented by time to market, being flexible things, innovating. At the end of the day, you're building applications for usually your business constituents. You're trying to create that next disruption. You're trying to innovate and drive that change. Then if you're an ops guy, like if you've had to carry the pager for a while, what are you incented by? It usually starts with stability. Right? Those applications that were created and deployed, you tend to be the one that's supposed to not let them stop running or fail or fall apart. You also usually are the poor person that writes the checks at the end of the month. You control costs, right? Whether it is a check to your hardware provider on hardware refresh rates, or if it's a check to Amazon these days, you tend to be the one paying that bill and trying to control the cost so that applications, as they scale and get used, that you still have bounds around them. And then the third thing, which is usually the least enjoyable of this, is you now own security and compliance. Right? Security is an ongoing challenge. Once these applications are written, you have to make sure that they are owned by you and not by somebody else. And then compliance, whether it's HIPAA or anything else, you own that operational state. So you might notice that the actual incentives on our teams, they're sort of at odds with each other. Right? Developments are driving to create things faster. Operations teams are usually driven to not create and maintain. So let's dig a little bit deeper into the developer themselves, right? Quick show of hands, just how many people here would characterize themselves as like they are in development, they're a developer, they cut code for fantastic. Okay, so for me at least, I'm used to development. It actually represents a little bit of yourself because it is innovation. It's something you create. It's showing your talents, your capabilities. There tends to be a lot of pride that's structured. You're reflecting what you can do in your applications. You're not just getting the job done. You're not just finishing something. But you're actually trying to really make an impact with it. If your job was to create a racing horse, you're not just going to settle for like a run-of-the-mill draft horse, right? You want to create a quality that is seldom seen. If it's ever been seen before, I'd characterize that as you're trying to create your Triple Crown winner. It's something that people don't see. It's going to be how you reflect yourself and your talents and your skills. You're really going to strive to build that. That's how you're going to channel everything that you can do. You want that delivery to be so powerful that it can really drive one of the next business disruptions. We hear about them all the time, whether it's an Uber or an Amazon, companies that use technology to such an advantage that it just disrupts an entire business. That's usually what you want to create with your applications. Now, the challenge is those applications can't live on your laptop, right? These are problems that have existed for a long time. And when it leaves your laptop and it's going to go over to that other team, with whom you don't eat and with whom you know different things, and you want to see your Triple Crown winner running in all its pride and glory in production, what happens in that question mark? Mapping your application to your actual operational environment, a lot of things happen, but I think we could argue most of them today aren't good, right? And this isn't a new phenomenon. Over the last 20 years, bad things have happened in that question mark. Now, 20 years is a long time, right? So how can we actually go that long? It's not like we don't have concepts of how to do this better. The early concepts were, well, we can break our applications up into smaller pieces, right? We started with, I dealt with a lot of releases, whether you call it a forklift release or monolithic release, where it was all or nothing. Like, you're going to deploy that application, and it was either going to fundamentally work or it's going to fundamentally not work and fail. And more often than not, they failed. And so, like, man, that's bad. I'd rather have 90% of it than 0. So we're going to carve this up into components, and that's going to let my ops team map those components to the infrastructure, because I don't know what the heck's going on over there. And we called it things like service-oriented architecture or microservices today, to be able to break these components up to smaller pieces, with the theory being that your operations team, knowing the infrastructure, would be more apt to take your components and map and be able to scale them and use them. Now, the challenge with this is, if you actually look at what this looks like when it played out, it didn't quite look as clean as it did on the drawing board or the whiteboard when we built it, how it was supposed to segment and separate. Looks a little closer usually to like a vase my kids dropped on the ground and glued back together, where like it sort of resembles that same looking application, but it's missing some pieces, and some pieces were glued in the wrong spot. Really, the challenge with this is we've never had enough of a common understanding or a common language, really, to even describe how our applications should map to that operational world. And this has plagued us, literally plagued us, for decades in software development. Now, the problem is a little bit harder than it would appear, right? It's easy to say, well, we need to build super engineers, right? We need engineers that are going to learn everything about development, and they're also going to understand everything about operations. It can't be that hard. But if you look at the pace of innovation and the depths of our domains, it's a lot more challenging. So let's look at the actual developer domain for a little bit. Your domain of expertise usually centers around your application. You wrote every line of code. You wrote your tests. You wrote your documentation. You were the one that put that crazy comment in about some challenge so that if someone picks it up 5 years later, they'll understand and not change this block of code. You know arguably everything about your application, whether it's a web application or mobile. That's where your domain starts. Then you move into your dependencies. If you're a Java developer and it's Rest Easy or Hibernate or Spring, you know a heck of a lot about your dependencies because you work with them every day, right? These are the things that arguably make your app function. You might not build Hibernate yourself, but you know every in and out. You know how to make it work. You know how to make it work for you. So you're very, very strong in your direct dependencies. Now, the challenge is when we move to the dependencies of our dependencies. And I will admit, so if I said, look, draw me a line from where the traditional Rails application or EE application, the actual dependencies it has on glibc these days. Like, I know it's there, but it's a little foggy because I'm not in that day-to-day business. I know the connection is there. Another classic case is something like Openssl. You might know that you depend on SSL to some extent, but then when it gets into your actual production environment, like, is SSL terminated? Is it terminated at the edge? Where? Does that SSL connection make it all the way back into your application server, or does it stop somewhere else? So these concepts are actually, the surface area is much, much wider of the dependencies that you have, and your knowledge gets a lot weaker in terms of how you use them. And it's not really at fault. If you look at the amount of innovation that occurs just in your application world and in your direct dependencies, it's very hard to have an expert level knowledge below that. Now, if this is the developer world, we have the same challenge on the infrastructure side. Arguably, the last 5 years in infrastructure, from the creation of the public cloud, to Zen moving to KVM, to private cloud and OpenStack, all these capabilities, not to mention hardware innovations by themselves, the infrastructure world has this exact same challenge. To compound this, the operations teams, they start at infrastructure. That's what they know. They know the hardware they've got. They know their switches. They know their physical infrastructure. They're probably going to know their operating systems pretty well and what they're running and patch levels. But when you move up to the applications, things start to get a little bit foggier. They might be running hundreds, thousands. In our case with OpenShift Online, our operations team are literally running millions of applications. Now, how many of those applications could you really understand the ins and outs of them? Not many. A hint, like we do not have millions of operations staff on OpenShift Online. So you hit that same challenge where it gets more diverse and more fragmented as you move from the bottom, the infrastructure up. Now the challenge is when you reach this intersection in the middle. This is where dangerous things start to happen in that mapping of your Triple Crown winner to what it looks like when it's running in production. Now, a funny story for me, going back all the way to the late 90s, really. I was working in a startup where our balance looked a little more like this. We didn't know this at the time, right? It was the late 90s. We were building the next generation photo application. That might not sound too cool these days because you have Facebook and Flickr and Google Plus and everything you'd want. But at the time, digital cameras were still sort of blowing our minds there. So this was like the bleeding edge of applications. And we spent a ton of time on our app itself. We're having to tune for 14.4 baud modems that were still out there and getting web pages to load in 7 seconds and all the web technology that was pretty rough around the edges at the time. But we got it functioning. We got our application running, and we were Linux guys. We stood up on Linux in our sophisticated hosting center, which was the second floor of this guy's house. And we had a redundancy of 2 machines that were plugged in. And that was it, and that's what we were running. And it was pretty good. In the first couple months, things were going great, right? We didn't even, no worries. I don't need the bottom part of this pyramid. And then we walked in one day, and we checked our monitoring system. And by checked our monitoring system, I mean pop open a laptop and look at the website to see if it's still running. And it wasn't. That was late 90s sophistication. We were hot stuff then. And so the site's not running, so we go check the servers. And we get a boot error on the first server, the hard disk went bad. No problem, we're going to go to our failover. We get the same crazy sort of error there. And we start digging into the servers, and they're gone. They're just like someone came in the night and formatted our machines. And we might have never known what happened, but luckily the Department of Defense contacted us and let us know that our machines were taken over and used on an attempted exploit with them. Now, luckily we were able to prove our innocence because we didn't know what the heck we were talking about that they were asking us. But this was the challenge of the danger of not knowing those dependencies. At the end of the day, we were just running a service that had a remote exploit that somebody could privilege escalate, get onto our machines, and do whatever they wanted. And then when they were done, they figured they might as well clean them off so that they wouldn't be any use to us anymore. So I think we could agree that having that knowledge is better than not having it. At least in my example, it certainly was. But the challenge we get back to is, what do we do for this question mark, right? If we go all the way back to you created your Triple Crown, you created this thing you are proud of. And you go hand it off to this other team, it's left the gates, you see it rounding the corner, you're pretty excited usually because this is going to be your application, not on a laptop, but more powerful, more capable. It's really going to be your idea come to life. And it doesn't look like a Triple Crown winner anymore, usually when we see this deployment, right? And you hit these challenges in defining what you wanted. You were building for a 1.25 mile race at the Kentucky Derby, and your ops team was planning for a race in the desert. And you were tuning for speed, right? Short speed, and your ops team was like, well, they needed water retention. That's what they were tuning for. And you were shooting for a 110-pound jockey, and they were building a camel. It could carry 5 jockeys. Those things don't even matter. And this mismatch in expectations and understanding and desired intent it creates these gaps that are just sometimes shocking. Now, for those of you that have seen something like that, you've seen your Triple Crown winner turned into a camel-looking racing thing, you know the feeling. It's really frustrating. At a minimum, you could say your idea for the next Uber or the next AWS isn't going to happen, right? Because if your innovation gets that distilled and that limited or that twisted by the time it's running, you're not able to take advantage of the infrastructure that you need to actually be successful. So this is the chasm, really, between development and operations today, that if we can't close it, there's just going to be a level of resistance that if you can't overcome that level of resistance, you're not going to compete. You're not going to compete in the next generation of ideas. Now, if this was the depressing part of the talk, the good news is I don't think all hope is lost here. I actually think with Linux containers, we have a technology that it's not just cool. I mean, it's cool stuff. I like the technology. I worked on it for a while. But it's about the placement of technology that's going to count. We've seen a ton of innovation over the last few years in each domain. We've seen a ton of innovation on the development side. We've certainly seen a ton of innovation on the infrastructure side. But the challenge is that each domain really doesn't need much more innovation. We need between the two groups to be able to improve the rate of development overall. So Linux containers, I think, is squarely targeted on this gap. Let's talk about how. Let's talk about some of the approaches that they take for it. So the first thing is, if we look at Linux containers, most people are familiar with Docker. Most people are familiar with the Docker format. And the concepts in this are pretty simple. The concepts have actually been around for a while. The first is we're going to segment the running workloads from the underlying environment. This might sound a lot like virtualization, right? You have your hosts and you have your virtual machines, but this concept of layering is very different. Now, if we look at the structure of layers that come together to form a container, you're usually going to have multiple things that can be contributed by different teams. You as a developer, you are obviously going to own your application layer. That's the contribution you know. That's what your domain is centered around. Most cases, you're probably going to know your runtime as well. You're going to know the difference between running on Tomcat and running on JBoss EAP. That tends to be in an area where you're in your app and you're in your direct dependencies and you're really comfortable. You can build those layers and contribute them. But now one of the challenges in your current world is the operating system was largely owned by the operations team. There were these challenges of like a yum update at 3 a.m. might break your application just because they were trying to patch a security update. With Docker containers, all of the dependencies you need are packaged up into your container. So that changes things a little bit. You now actually own and are accountable for a portion of the operating system. Now I say a portion, that's really important because if you remember my story, when I owned the whole thing, we didn't really know what we were doing, and that had bad results to it because my domain of expertise wasn't strong enough to really understand all the ins and outs of managing that operating system layer. But with Docker, that operating system layer can be minimized to exactly what your application needs to run, and it can actually be contributed by a different team. Your operations team is probably going to be a little bit better at building those base layers, the minimal dependencies for the operating system, that you can build and layer on as an application developer. So this is pretty powerful because it gets us to the first point where we can really have both teams working together to create a concrete deliverable. It's a single container, it's a single application. You own the deployment process as a developer. You own and get to pick what layers you depend on, what layers you choose. The authority and the accountability comes with that. Now this is pretty powerful as well because now on the operations side, they get to focus on a runtime that is separated from your applications. One of the challenges I hit when I shifted to PagerDuty and I went over to operations was the challenge I would summarize as like, hey guys, install me Node.js on those production machines, or install me this new, Java framework. And in the process of doing that, you would pull down hundreds or maybe thousands of packages and pull in these crazy things like Firefox or Eclipse into your production environment. And it was very nerve-wracking on the operations side because your job is that runtime. You need to harden that runtime. You need to make sure that security is built into that layer. you don't want your domain of expertise distilled by all these other things getting put into your operational environment. So this structure of separating the containers from what you run the containers on allows both teams to really start to tune to what they know. Now, this is on the initial creation of you as a developer creating your Docker file for your application layer and another Docker file that you depend on for your runtime layer. And you're going to get a minimal operating system from your ops team. You guys are going to work together. And you're going to pull the three together into a single container. The initial creation isn't everything. Right? The minute an application is created, it's put into production, what are you going to do when the next shell shock comes out? Or the next Venom? Or the next Poodle, or the next Ghost, or the next, these are just the ones with like big names that we know and we've heard of, or the other 8,000 that probably occurred of security challenges. What teams are better equipped to actually see those, track them, and tell you whether you're updated or not? The 3 a.m. Yum update example that I gave you, that's the bad example for my life, right? Ops teams tend to know when these things happen, and their only recourse today is just to update the servers. And it breaks a lot of applications because they don't understand the dependencies. In the Docker model, your ops team can still find, they can still patch, they can still respond. That is their domain. That's the center of their domain. But now they can contribute that layer back, and you as a developer get to make the actual concrete choice whether you're going to deploy it or not. This refinement of our roles and responsibilities, when I talk about working a technology right into the gap, is critical. Or at least in my experience, these have been some of the tools that are missing. Virtual machines and virtual appliances do not get you here. Virtual appliances, if your ops team just runs the hypervisors and the development team runs the VMs themselves, you get back into my startup experience. But then if your operations teams own all the VMs and you can't apply any updates to it, it becomes very challenging on the development side because you can't introduce the things that you want. This separation actually opens up a tremendous amount of choice as a developer. In fact, I would argue that all of this innovation that we've seen, all of the languages and the frameworks and these things that are out there, but that haven't had the scope of impact we've wanted them, a lot of them is because of the friction they introduce on the operational side. And the nice part is with this separation, you as a developer are much more liberated in terms of what tools you're going to use to build your Triple Crown winner, right? If you want to use the new language and you know where you're getting that from and you know that content, you're not going to be affecting your operations team's ability to do their job. So that's a very powerful thing. These are capabilities introduced that you'll be able to use that in the past you might not have. Now, one of the challenges with that is it does put more responsibility on the developer. Choice is now constrained to you, but you could still put rootkits or exploits or those things into your environment. Now, as a developer, when you're making that choice, it's not complaining to your ops guy because he won't install Node.js or he won't install Tomcat. It's actually your decision to make, but you have to know your content. You have to know your source. But for me, I would always rather have the choice if it's something I can use to my advantage. So does this get us back? If we look at, we have the dependency and the separation of roles, and then we have this ecosystem of choice. And with Docker formats, by the way, you probably have the widest collection of packaged software that you're going to find these days. Any technology, you're going to find 500 different things packaged. You have to be able to make the right trust. Which ones do you trust, which ones you don't? But there's a huge and growing ecosystem there. But does it get us back to our Triple Crown winner? And it's closer, right? We have a better separation of controls. We have better choice. We can use those innovations that haven't had as much impact as we wanted, but it doesn't get us completely there because everything we've talked about today is about running a single container. And while that single container represents the core handoff between teams, nothing runs at that scale. No application, whether it's multiple tiers or whether it's when it's used, you need to scale it up, is going to function in that same environment. So you scale these concepts we had in order to succeed. Now, when it comes to scaling, you actually need a way to describe how your applications are going to map to your infrastructure. It's not really, reasonable to expect your operations team to understand all of these. The way you're going to scale a MySQL or Apache is fundamentally different. But when we think about Linux containers and Kubernetes, you first start to get that ability to describe how things are going to scale. The way Apache is going to scale is going to be different than MySQL or even Mongo in creating replica sets, but having the ability to describe it and just describe the scaling rules and patterns are critical. This is actually where Kubernetes comes in. Kubernetes introduces concepts on the development side to allow you to start describing the patterns of how your application should work. You have things like pods, being able to describe which containers should be co-located and are going to use resources together. You have things like services that are going to describe how you're going to access different components, and things like replication controllers that are actually going to start defining how your applications themselves will scale. Now, this is going to be the core thing of letting you describe the Kentucky Derby as the race location instead of the Sahara Desert. We don't want to leave these things up for chance, but we've been doing it for a long time, right? We just sort of take the things that we know. He's like, well, I built my JBoss application, and obviously my ops guy who is dealing with 500 of these is going to know how to do it well, so I'm just going to give it to him, hope for the best. This is our first touch in having a technology that, as an application developer, everything from co-location to anti-affinity to where things should land to your network dependencies and your storage dependencies lets you start describing just enough to give your ops team a chance in mapping it. Now, if we look at the operational side themselves, this lets them approach the problem in a little bit of a different way as well. They're going to get to use the tools that they know. Things like managing overlay networks, because your description in Kubernetes is largely going to constrain things like these two pods need to talk to each other. They need to have IP-level access to one another. Your operations team can solve that in a variety of ways. They can use technologies like OVS and Openssl and these capabilities to build it, things that they're comfortable with to meet your need. Part is if you look at challenges like storage, they're able to solve storage by creating storage providers and solve it in a general context, and then allow Kubernetes to actually utilize those providers and fulfill them to your application. It's the first time where operations teams can use Kubernetes to actually translate across this chasm, which I think is really key. I think this has been one of the missing areas between teams is we haven't had the common language. We haven't known enough about each other's domains, and I would argue I don't think we're going to. They're too specialized. They move too quickly. We need this translator in the middle. And it's going to be a balance, right? Are these exactly the right things today? If in Kubernetes you can describe compute, networking, and storage and concepts of co-locality and those things, I'm not sure, but I think it gets really, really close. I think it's the closest example that I've seen in a decade to this. When you get to this point, I actually think you will be at the spot where your infrastructure can start working for you. And with any new technologies, any of the ones I showed you before, any of the languages, any of the frameworks, any of the process improvements, there is an investment to learning these. You can't just keep developing applications the same way you did every day. It's like, well, now I'm going to use Docker and I'm going to use Kubernetes. In the case of Docker, if it's going to be understanding how you can better run containers in a single process model, or if it's in Kubernetes, actually getting into how would you map your networking requirements? What things should be co-located or not? These technologies will be an investment to learn, but I think these are going to be the technologies that are going to separate companies that can leverage their operations and development teams to overcome these barriers. And to be honest, the timing, I don't believe, has ever been better. There has never been a point that I can remember where you started with effectively limitless infrastructure at your fingertips. Whether that's in the public cloud, in Amazon, Google, Azure, whether it's on-premise with OpenStack, the ability to have unlimited infrastructure really hasn't been there in the past. So that's not a limiter for you anymore. Then on the development side, we actually have more languages and capabilities, whether it's solving big data algorithms or whether it's building better web frameworks, than we have ever had before, and they're very capable. It is amazing to me the refinements that have been put into these technologies. So on the development side, we have more tools than we've ever had before. The infrastructure side, we have more resources than we ever have before, and we have fundamentally new mediums now. If you look at mobile or Internet of Things, or being able to utilize the data that's created with these in big data, you have completely new ways to reach users. But the challenge is going to be the only people that are going to be able to take their ideas, their innovative ideas, and actually use infrastructure to make them work are going to be the ones that can cross this gap. So the last thing, I think, is for you guys if you decide to take this on, you decide to invest, you decide to learn it, it's really to build something great. Don't accept any of the limitations that you've had to date. Understand these things and really put your innovation and your creativity to the test and see what you can create and be the next disruptor in the industry. So thank you very much. I hope you've enjoyed DevNation so far. If you want to see some of these technologies or dig in deeper, we have a ton of sessions on them. We have booths. I didn't do my time check. If I have time for a couple questions, I'll take them now. But we have a ton of resources here at the event, both at DevNation and at Summit, if you guys do want to learn more and dig in a little bit. Thank you very much.
Thanks. So why don't we do maybe a couple of announcements for everybody, and then for those who want to stay, you want to stay for a little bit and do some Q&A?
Sure thing.
All right, cool. So we have a little bit of time. The next sessions are starting at 2:45. We have 2 session blocks left, and then a little bit of a break and the code challenge tonight. So a show of hands, who's registered and done their homework to register for the code challenge will be coming. Then it looks like many others still need to do that. So try to so we don't get locked out. Or don't come, whatever. But yeah, so 2:45, back downstairs in the main hallway. We've got kicking off with a talk on Shenandoah. There's a garbage collector for Java. There's a talk by Paul Backer on Kubernetes, fittingly enough. We've got a Java EE and front-end talk by Xavier Kulan, a whole bunch of other great stuff. And I guess you have until then to do some Q&A and hang out. So give them hell. Bye, guys.
And I think, so raise your hand if you want to ask a question. I believe we have a mic sitting around here, and I'm a little blinded on the left side, so if you can shout if we don't get to you quick enough. I can't see. Oh, one up front. I think maybe one in the back, but I can't.
Jan Wildeboer, also from Red Hat. Simple question. My personal problem with all of this stuff is, in the case of Kubernetes, what is your opinion on the sustainability and API stability and everything in Kubernetes? Is this more or less cast in stone, or will this be agile, radically changed every 3 months so we can start all over again? It's a little bit provocative, but you get the gist.
I think my mic. So the question was, which I think the mic was working, was basically, are these things set in stone, or are we going to churn and redo and rebuild this every 3 months or so? And I think it's going to be the balance of, one of the reasons that we really focused on Kubernetes was Google has had, we think, I've spent the last 4 years on OpenShift, that we have quite a bit of experience running this at a pretty large scale environment with OpenShift Online. But when we started talking to Google, Google actually runs this at a much larger scale for a much longer period of time. Technologies like Borg and redoing that to Omega, they run the vast majority of their infrastructure on containers. So one of the reasons we were drawn to Kubernetes was we saw this need, we'd done a ton of work, we wanted things to converge, and we actually thought working with Google was going to bring us a little bit more of the stability than if we just created it ourselves based on what we knew. The challenge with that, though, is I don't think we're done by any stretch, right? If you get into areas like how should storage provisioning and providers and allocation and requests work, those are areas that are going to continue to evolve, especially because storage itself is, whether it's Ceph or Gluster technologies, those. So I think you'll see areas that are very stable. The concepts, the core structure of pods and services and replication controls and routing, I think will stay fairly consistent. The how you fulfill those, are you going to use OVS or Openssl? Are you going to integrate with specific hardware providers? I think you'll see a lot of innovation in those areas. My hope is we keep enough of the API sanity that you do your investment on the technology once, and then you can get to continue using a long run of innovation going forward. But those things are never sort of known. But that's my hope, right? That's a little of the background as to why we did that. So was there a question in the back? I couldn't really see in the back. So raise your hand and wave it if you have one. Oh, I know I see one.
Hi. So at the moment, when you have the entire stack on the machine, the ops team wants to update because of security issues, for example. Mm-hmm. So it could break the application, but it usually doesn't. And so they do the update, you restart the application, it uses the new shared libraries, and it can continue running. With the shift of using layered stacks, if there's a security issue at an intermediate layer, it seems like you have to redo the entire layers to have the full stack again running in ops. So what happens when there's a security issue? How can you easily and quickly redo the entire stack? How are you supposed to do that?
No, it's a great question, and this I think is one of the challenges with the direct technology. So I'll actually answer this from an OpenShift perspective of, is that built into the technologies themselves? No. Do you have the ability? Do you have the ability to solve that yourself in a variety of ways? Yeah. So in OpenShift, what we focused on, and for those of you who've tracked OpenShift, we really have built the core of OpenShift around Docker and Kubernetes at this point. Our goal has been to build in enough structure from moving all the way from source code-based applications to that fully composed stack, that if either side introduces a change, that development can actually rebuild that entire stack and chain and redeploy it, or the operations team themselves, having access to it, could rebuild that entire stack and deploy it. And that gets into making sure you have builds available, right? Being able to detect a chain and then recompose images. It gets into making sure that you have deployment capabilities set in. Once that build is actually done, you don't want your ops teams to have to figure out how to redeploy it, right? That's sort of a development-defined area. And so those are capabilities right now that aren't built into the core of Docker and Kubernetes. But we've taken the approach of being very prescriptive in how you can address those things in products like OpenShift, as well as in the community like OpenShift Origin. A lot of the operational side as well, and it really gets down to a shop by shop, right? Some shops will want developers to truly wake up at 3 a.m. and push the button if test their application and redeploy it. In a lot of cases, I don't think that's necessarily feasible, and so we don't prescribe who pushes the button. We want to make sure that from a source-based application that you can rebuild any layers in the chain and actually go all the way through a deployment that you described with some automation and some ease. But it's not built into the core itself. I didn't talk about this because I was a little bit more focused on the capabilities, but it's certainly accomplishable. You just need those higher level concepts to do it. Does that help? I can't see you back there, so hopefully that answer enough of it. Or
is there any plan to on the lower end side to include those features?
Yeah. So one of the things right now at this point, we're the top corporate contributor to both Docker and Kubernetes, and one of the reasons for that is every concept we have, we tend on OpenShift to have started from what's a problem the users need to solve. And we make sure we have enough understanding of the technology to solve it. Then the second phase we go through is where is the best place for that technology to land. It could be in the operating system itself, like we make a change to the kernel or the user space libraries. It might be in Docker itself. It might be in Kubernetes. So really over the last, 18 months, 12, 18 months, we have been pushing a ton of features lower and lower in the stack where we can actually drive them into the communities and where there's agreement on an approach. One of the challenging things I know in that space is everybody does those operations a little bit differently. So it's a harder one to converge on. But anything where there is, dissent or multiple options that people have, that's what we use our landing spot for OpenShift Origin to keep those technologies there. So we'll keep certainly pushing more things in. I think as they stabilize, you'll see more and more capabilities move lower in the stack. Just sort of the nature of the beast of how these things have worked.
Thank you.
How would you compare the orchestration of the Docker containers from Kubernetes and Apache Mesos? I mean, are there overlaps or it's kind of a completely different technology?
Yeah, so Mesos, we actually quite a bit with Mesos and even similar areas like Yarn technologies. And I think those technologies were born of the concept of being able to manage all of your data center resources, right? Hardware, physical machines, virtual machines, being able to apply workloads on those. I think they generally started from the world of maybe the multi-tenant drive, but being able to understand resource allocations pretty well. Kubernetes is certainly in a similar space, right? If you look at the high-level concept, they're taking a pool of resources and carving them up into containers. But I think they have slightly different intents just on the structure of they tend to be very container-focused in terms of workload, whereas Mesos tends to be a little more general purpose in terms of what they want to understand. Have seen concepts like, I know the Mesosphere guys have been working on plugins to have Mesos coexist or cooperate within Kubernetes. So I think you'll see a lot of innovation. But the technologies themselves are a little different. I tend to think of if you're going to be focused on containers and focused on a specialized container scheduling, Kubernetes is probably going to be a little bit stronger. If you're focused on general purpose scheduling across workloads on VMs or hardware or big data workloads, Mesos is probably going to be a little bit stronger today. And then hopefully we see more and more collaboration between the two technologies as it goes forward. And I do not see any more hands, so I'll do the 3-second count. And if nobody's got them, thank you guys very much. And you can find me in the halls. I'll be here today. Thank you.